Hello everybody, I am Laura Dale from LKV Baden-Württemberg and I would like today to present you the influence of the energy balance at the insemination day on the fertility and the pregnancy. During the last 15 years, different researchers were developing new calibration models linked to milk main components and also to the standardized spectral data. In the last 10 years, it is possible to develop, to share and to use common in Europe at European level and to predict new phenotypes on the health, efficiency and environment impact for the dairy cows. The aim of this study was to see the influence and the impact of the energy balance at inseminations day. With the data from 12 optical test farms where feeding and breed experiments were combined with feeding intake data and the energy balance values were obtained and financed by the DLQ, MIR energy balance models were developed. It can be seen that the difference between 0.5 RPD between standardized and non-standardized spectra are obtained, but due to this variability, this data were put together and has a better robustness the model. I would like to point it out that an RPD bigger as 2 means a root screening for the model. In the early 2013, I have been part of Nicolas Gengler team. This team has developed the first model based on MIR spectral data, standardized spectral data, and pregnancy status information. The team pointed out that there is a strong link between pregnancy and lactation stage. Also, Bavarian team tried to build a model but was not successful, as also the Nicolas Gengler team. Late in 2020, the Nicolas Gengler and Hélène Sawyer PhD student, together with Australian University, tried to develop a similar model in Australia, but the answer was that in the first 100 to 150 lactation days, there is no possible to see this difference in spectral data. Meanwhile, my coffee team in Edinburgh developed a deep learning model where the cow pregnancy status was predicted in the MIR spectral data. Seeing all this information, it was decided to explore what has been wrong in the moment of the insemination and to try to have a better insemination rate. The LKV Baden-Württemberg objective is to help dairy farmers in close monitoring their dairy cows, including also detection of energy balance values and also problems of fertility. For this study, from the database of LKV Baden-Württemberg, 288 farms were selected, which took part of health monitoring program. Also, data covers complete 6 years of calving period and also complete variability of the days in milk for the population. Also, important breeds and season variability. Data is from Bentley Spectra and is standardized after OptiMIR EMR method. As there were a lot of affirmation in the last period, we decided to detect on the spectral data in the first 28 days in milk and also in the 4 to 8 weeks of lactation, the first insemination, if there are differences between standardized spectral data of an inseminated cow and not inseminated cow. As you can see here in green, it's not pregnant, so before being inseminated, and red after being inseminated. Also, in this build, it can be seen that there are differences after 2 inseminations for the cows between 4 and 8 weeks of lactation. Here appears also the blue cow, the open cow. So don't remember, green, not inseminated, blue, inseminated but open, and red, inseminated and successful pregnant. As well, you can see it with 3 insemination until 63 days in milk. It is possible also to see if a cow is open, not pregnant, or pregnant. The main reason of why we choose to study the energy balance was the Pearson correlation analysis performed between open and pregnant cows, and also all the milk components that are predicted from spectral data. The energy balance had the highest correlation with this information. In this slide, it can be seen the energy balance in megajoule NaL for primipar in red and multipar in blue, and also the milk yield for primipar in green and multipar in yellow. In the left side, it is possible to see for each lactation how the energy balance is changing, while in the right side, it is seen for each important breed how the energy balance it is for each lactation week on pregnant and open cows. Here you can see the energy balance on the left side for all farms, for Holstein farms, and also for the selected test farm at the first insemination, second and third insemination. In the right side, it can be seen the energy balance at the first insemination. Also, you can see here that the herd manager of this farm had chosen a late insemination period for their cows. As you can see, cows that are still open after insemination, they have a low energy balance in comparison with successful inseminated cows. Cows that are still open have an energy balance of -10, when the cows that are successful insemination had an energy balance of 6.6. The same can be seen for the cows with 2 insemination. The energy balance is lower for the open cow after insemination, while the milk yield is higher for these cows as for the successful inseminated cows. In the left side, it can be seen that the energy balance is less than -11 for the unsuccessful cows, while for the successful cows, inseminated cows, it's bigger than 9. In this slide, there are cows with 3 inseminations. Here, the energy balance is lower for the cows that are open after the insemination, and it can be seen that the mean value of the energy balance is -11, while for the successful is almost 9. Also, if we are looking here in this slide, we can see all farms, Brownsea farms, and one test farm, Brownsea. We can see that the energy balance is different from the Holstein to also to this Brownsea farm. You can see that the unsuccessful inseminated cow, the open cow, has an energy balance almost -2, when a positive inseminated cow has a value of almost 16. If we are looking to the 2 insemination, we can see the same. It's the energy balance for the negative cow is around 2, while for the successful inseminated it's around 17. When we are looking to 3 insemination for the brown Swiss, we can see that it's -2 for the negative, which so means that the cow is still open, and if it's the cow is successful inseminated, it's around 18. If we are going further, when we are looking to Simmental at first insemination, we can see that the energy balance is different and is more in the same area as for the cows that were Holstein cows. Here you can see that the cows that are not after insemination not successful, there are around -20 in the first insemination, while for the 2 insemination there is almost -21, and if we are arriving to the third insemination, we coming to -19. To summary, there are differences between spectral data after insemination. between open and pregnant cows in the first 90 days of milk. After checking the differences, it can be pointed out that there are differences at the first, second, and third insemination, and also that are differences between breeds. The energy balance in megajoule NaL around 0 had around 2.8 cows in brown Swiss, when Simmental and Holstein cow were around 4%. 12% of the brown Swiss cow were still open and had an energy balance more than 25 megajoule NaL, while Simmental and Holstein cow were around 4.4 and 4.9%. The equation for the determination of energy balance NaL and Ma are statistically highly meaningful and allow comparison between group of cows. The conclusion of this study underlines the importance of checking the energy balance level of the animals before performing an insemination. It has been observed that this approach could be used for further studies and to develop alarm system based on mere prediction of the energy balance for management strategy and to improve the successful insemination and also to reduce the financial loss. The further developments could be carried out at all levels, optimizing the farm level and the energy balance at dissemination period, reports and application for efficient insemination period, and also mere application reducing economical loss. Thank you for your attention. Also, I would like to thank you to Optico and DLQ for the energy balance equation, and also to CRAV and Optimir for 10 years of standardization. You need more information about standardization, please contact EMR.